So now we'll get into a little bit about the NID installation requirements. Some of the tool requirements are like a microduct cutter, cordless drill, and with the hex driver, drill bits, zip ties, and cutters.
All right. So the zip ties, I will withhold judgment for now, but
Okay.
there may be some controversy about the use of zip ties on fiber optic cable, but we'll table that one for now.
Okay. So for our FlexPond enclosure, and everybody has a different configuration of their NIDs, obviously. For us, shameless plug, I'm just going to go through the feature set because I think it's important for everybody to understand, the feature set and the parts that come with this. And so when you open it, why can't I see? I'm trying to see the screen. Give me 1 second.
Presenter view?
Huh?
Do you want to pop the presenter view? Do you have multiple screens or no?
I don't. Let's see. The view where I can see myself, I guess. So that's there.
Might be the presenter view.
Let's see.
So the name of the box is FlexPond, but obviously this can be used in any fiber to the premise application, not just PON, but even RFOG, if you were so inclined. Is that a fair statement?
That is fair. Okay. Now I can see you. I can't see me. But
I can see you. You look good today, Skip.
Thanks, Mike. Appreciate it.
Black shirt, that salt and pepper beard. It's a good look.
Just like yours. All right, I'm gonna try to go through it. I thought I could see myself doing it for purposes, but so now what happened?
We're just winging it, and Teams is not playing along. So
no, it's not.
There we go.
All right. So these are the components that come within the NID enclosure. And you have 2 hose clamps for mounting of whether it's microduct or the 3 millimeter. You got an input, you got an output going into the ONU or the ONT. You got your 4 screws for mounting. You've got your grommets that will serve as the entry point. These are actually grommets that will upsize the 3 millimeter cable if you're coming out direct. We'll upsize it to the 10 millimeter, which will serve as making sure it secures perfectly inside the NID enclosure, which I'll show you in a little bit. And then we have a ground block that really serves it's not a ground block per se, because everything that we're dealing with is essentially a dielectric. We don't have a need to ground. It's a termination point for the tone wire of the microduct. I think everybody who's tried to put a clamp onto a small piece of wire has found it very difficult. Whereas if you're terminating the tone wire to here, this is easy to bite onto with the clamp. So that's that purpose of that.
Yeah, so those bonding lugs are nice to have, particularly if you do ever have to locate that out, right? Because you can just connect the alligator clip from your locator right onto that bonding lug, which is connected to the tone wire, and then locate the duct all the way back to the PED.
Yep. Yeah, it just makes it a lot easier to latch onto. And so the one thing that you'll see is that the slack storage insert prior to the screws mounting into it, the 4 screws that go into it, this can be removed. So this is just a interference fit that goes into the NID enclosure itself. And that's important because when I want to install the hose clamps for the bonding of the microduct or the fiber cable itself, sure makes it a lot easier to install through the slots above and below it. Even this is difficult. So at least allows me to get it set in an open environment. Okay. Mm-hmm. And that could be true for both sides of it over here. And then once I'm done with my pre-assembly, and that includes, my bonding block, which just snaps in place.
So that'd be easy enough to do in your truck. So you could unpack all that and pre-assemble the parts onto the slack storage tray.
Yep.
Have your box pre-mounted in that location, and then just drop it in.
Yep. So you get all this pre-assembly done ahead of time. And then once you have all that, then you go to the enclosure. And then when you're ready to mount it, this goes back into position with the interference fit. And then I drive my screws into the 4 points that makes this a permanent portion of the base plate.
Gotcha.
And at my slack storage. Let's see.
Now this is storage tray. Sorry to interrupt. The one thing that we didn't talk about was the bulkhead, the SE UPC bulkhead that is mounted in the middle of that slack storage tray. That's factory installed.
It is
with dust covers. So
it is. Yes,
do we need to clean that before we install our fibers in there?
No, you won't, because remember that all these bulkheads are a pass-through.
Right.
So when I pull this out.
So those are just dust covers, and that's a hollow tube.
That's correct.
So you shouldn't need to put a swizzle through there or do any cleaning, provided that you do the fiber interface inspection and verify that both of your connectors are clean prior to installation.
That's the critical part. That's the critical part.
We talked last time, the one that you have in your hand is green.
Yep.
But the one that's in the picture is blue.
Correct.
And that doesn't matter.
It does not.
Provided that your connectors are the same, either APC or UPC.
That's correct. And again, like I think that, as we went along and we started getting the requirements from customers going, hey, I want my FlexPond with, a bulkhead that's UPC, which would be blue. And then we started getting requests for APC, right? Which is green. And I think at the end of the day, it just simply caused more confusion to the point where we recently, made the decision, rightfully so, that, the bulkhead shouldn't really have a color to it. It should be agnostic, because there is no difference other than the color of what you see on the PowerPoint versus this. Mechanically, these things are identical. And to your point, like we talked about before, what's important is the connectors that go into this need to match the same color.
All right. Well, I'm going to make an executive decision, Skip, and you heard it here first, that bulkhead should be pink.
Pink?
In every application, because it doesn't matter. Because, pink goes good with everything. Could be blue connectors, could be green connectors, doesn't matter.
But we've already started with black, Mike.
Well, all right. Feel free not to use my, suggestion, but if it does take off, then I will have gone on record as saying that the bulkhead should be pink.
Fair enough. Fair enough. All right, let's see. The other nice feature about this NID enclosure, the way that the hinge is locked together, and I can't see myself, so tell me if I need to line this up, but what happens is as I start to close the door, it locks in position. So if I'm working on this and I got a windy day, it won't allow the lid to close up as I'm working with it. So that engages that lock feature to it, so it doesn't keep getting in my way. And simply to release it as I just lift up the lid, and it allows me to swing it back and close it permanently. It was a little bit hard to show in the presentation, so I thought, having a couple props here would show it a little bit better.
Yeah. No, I think I can see it now. So effectively, when you open the lid on the NID, the lid's going to drop slightly, and that'll hold it into that locked position. So there's a lot of different lock boxes out there, different types of configuration. And yeah, some of them, you have to close it and then push up to lock it, or, flip it open and push it in. So Yeah, just understand the piece of equipment that you're working on, but this does have a handy dandy auto lock feature to help keep that open while you're working in the NID.
Yep.
All right, good to know.
And then there's the FlexPon reel itself, which is just a pre-coiled, in this case scenario here, this is the drop that would go from the NID into the ONU. And this small little reel contains 190 feet of cabling. They come in different lengths. You don't always need 190 feet from the NID to the ONU, or the ONT, but we do it in like 50-foot increments, 100-foot. But it's a nice pre-slacked scenario that with one screw will mount to the back plate of the lid itself and allow you to pay out on a spool system to peel off as much cable as you need to go into the ONT.
That's handy.
Yep. And then the grommets are like a pyramid type system. And so for 3 millimeter, which would be the top one, I've used my fiber optic shears and cut that open. It leaves me an opening that will keep out, the bugs and the unwanteds, and allow me to go up through the 3 millimeter. If I want a 8 or 10 millimeter duct, I go to the next pyramid that allows the opening to be a little bit bigger. And then simply, once I have that set, this will fit into the enclosure from the bottom up. It has a little lip.
And then you'll feed your duct up through that. And then going back to the reel, so the external part of the reel is the ballistic end,
Correct.
which you would play from the NID or into the microduct in the NID, and then pull that back to the PED. And that's where you would install that hardened outdoor connector, right?
Actually, the reel is from the bulkhead, so one end is finished. Mm-hmm. And so this end would go into the bulkhead. Right. The opposite end, which is also ballistic, would pay out and go along the sidewall and go into the premise and terminate to the ONT.
Oh, I see. Okay. So this is not going out to the pedestal. This is going into the ONT or the ONU.
Correct.
Gotcha.
So I would have, once I'm done, and I might be getting ahead of myself. Let's see. Yeah. So once I get the grommets and the back plate all the way in there, secured, then I'm going to come up through with my microduct over on the right side view and secure it permanently with the hose clamps. And I would go ahead and pull the ballistic end from the nap all the way through the buried microduct and come up to the top through here. And then this would be my slack that I would have for whatever's left that I need and terminate to the bulkhead. And then the reel would then be over here connected, would connect up to the bulkhead, and I would pay out and then over into the prem.
Gotcha.
Okay.
Now, 190 feet sounds like kind of a lot, right?
It is.
And if we're thinking about coax, so the reality is you can go a very long way to the ONU or the ONT, whatever, with that 190 feet.
Yes.
And then the excess just stays in the slack tray or
That's
the
right.
coil. Because, in coax terms, if we're thinking about, 1 gigahertz system and the amount of attenuation through 190 feet of RG6 is kind of a lot.
Yes.
Except we're not talking about coax. We're talking about fiber and wavelength, which, 1590 or 1310 or, almost regardless of the wavelength, the attenuation in 190 feet of fiber optic cable, provided that your end faces are clean,
yes,
is so negligible as to not even talk about it. Because I think at 1550, it's like 0.25 dB per kilometer.
I think
so. It's not a lot.
It's not. And to that point, what's really important is, since length of cable doesn't matter, what does matter is protecting the cable. For example, if I'm going to pay out from my reel going into the ONT, I want to minimize how much exposed cable I have. And so you got to think about where's the best location for the nid especially if I'm doing this from scratch. Hopefully I can position a nid so where it's favorable to the customer, to where I have a very short distance before I go into the house. You don't always have the case, but you want to minimize how much exposed cable you have on the outside of the house. That's probably the most important part about where do I set the nid? Where's my entry point for the cable going to the ONT? Because, yeah, distance doesn't really matter, but exposed cable does. I mean, if you're going to go from the front of the house all the way to the back end of the house for entry, you got a little bit more of the exposure there for things to go wrong, weed whackers, God knows what else. But I think that's the focus of where you need to think about is I want to minimize how much exposed cable I have on the exterior of the home.
Yeah, I had to fact check myself because I knew somebody would do it if I said it out loud. What the optical fiber loss of single mode fiber is, and it is 0.25 dB per kilometer at 1550 nanometers and 0.35 dB per kilometer at 1310. And we're talking about a couple of hundred feet. So significantly less than, kilometers. So, the loss is negligible through 190 feet. So technicians, if you're getting spun up because there's a whole bunch of cable left on this reel that is introducing additional loss that you think may not be necessary, in terms of optical path loss, it is negligible. And
it really is.
When you look at the inner diameter of that spool, it doesn't exceed the minimum bend radius, right? So you're not going to have additional loss because of a micro bend or something. So it's really negligible.
It is. There's no negative effect to that bend radius that's on that reel. Yeah, and that,
okay.
And that's true for the, introduction of bended sensitive fiber. That's now pretty much de facto standard today. I mean, there was a time when fiber was first introduced where the bend radius would actually start to create attenuation to the point where they would actually make, miniature spools that if you wrapped a fiber around it so many times, you could actually calculate how much attenuation, if you wanted attenuation, you could do it that way. But that I think from normal use, folks wanted something that actually did not introduce path loss to the fiber if it was in a very tight, bend radius or whatever. So even that has really dramatically improved the path loss. I mean, you can get that thing pretty small, like for our bend radius for 3 millimeter, this cable itself is 10 times the diameter of the jacket itself. So that's, 3 centimeters. And that takes me a lot to get even to that much. And even that is not going to create any type of path loss if I do that.
For those of us that have been around a while, we do remember homemade optical attenuators. I have seen, and I will remove the names to protect the guilty, optical attenuators using a pencil and tape, where you can actually take a inside plant fiber jumper and wrap it around a pencil, almost like an inductor coil, right, around a pencil, and then tape it. And the number of wraps and how tightly you wrap it around the pencil will determine the amount of, it's basically scatter loss because of the bend radius.
It's too tight.
And you can actually tune your optical path loss pretty well with a pencil and some tape. Now, don't recommend it. This is not a best practices video for building homemade optical attenuators. However, I have seen it done. Now, in this scenario, modern fibers, good quality products like your FlexPawn box, like we're not going to worry about that because it's not likely to be a problem that you're going to have to troubleshoot later of excessive loss in the drop fiber, right? So if your light level's low into your CPE device, your ONU ONT, it's likely not because of the excuse me, the amount of fiber or the bend radius. Please continue while I cough to death.
So here's an example of the ballistic coming in on the right view. This would be coming from the pedestal. And then the back plate on the left view, you have an area that serves as slack storage. I complete the connectorization of the ballistic end, and I'm going to couple. And prior to coupling, I'm going to make sure that that fiber end face is clean before I plug that into the bulkhead. Clean the connector.
I don't think
So
we talked about that yet. Skip, are clean connectors important?
They are extremely important, like more so than bend radiuses or anything else. Is like the most important aspect of the connectorization or the assembly process of coming from the nap all the way into the ONT. Extremely.
All right, good to know. I feel like that might be mentioned again before this is all said and done.
I know.
Just a guess.
I'm wondering if we're going to have time, but I don't know how much time we're into it, but we'll keep going. And so this would be the FlexPond reel. This would be the drop side, like I talked about before, where you would pay it out to the other exit grommet going over into the premise, wherever you needed to go alongside of the exterior wall of the home or whatever the exterior substrate is, and then punch in and hopefully behind it hit a wall plate, and then from that to the ONT. And then this completed end would then be assembled into the bulkhead. First, you would clean the connector and then assemble it into the bulkhead. So that gives you that connection point. Here's an interesting fun fact about when you connect to this bulkhead, both ends, there's the amount of force that you push against the body until you hear a click. The amount of force that these two connection end faces have against one another is 4,200 psi per square inch, which is an incredible amount when you think about it. And then if you think about any amount of debris or even the slightest amount of anything that's going to get smashed between those is quite considerable. Hence the importance of cleaning.
Say that number again.
4,200.
4,200 pounds.
Square inch.
I'm looking up how much my truck weighs.
Yep.
I'm pretty sure my Ford F-350 Super Duty diesel truck. It might actually weigh more than that, yeah. But it's still a lot.
It is.
Probably more than a Bronco.
It's a
Not
lot.
suggesting that you should park your Bronco on the NID in the completed connectors. However, that is an interesting fun fact. Thank you for sharing.
Yep. When I first heard it, I'm like, "Are you sure that number's right?" I'm like, no, that's right.
That's funny.
And so this kind of shows you, like, if you're coming into the bottom grommet, it's kind of a bad picture, but these are these little step-up grommets that would fit into. It would go over the 3mm jacket itself. Has a little slit in it, and you just slide it over to the 3mm jacket. So now it kind of upsizes it to a 10mm, so that when I'm going to secure it with the hose clamp, it's the same thing as if I was having a 10mm micro duct coming up through, and makes it very, very secure.
Yeah, so I think because it's microduct on both sides, right? I don't think that there's going to be a lot of force on it, but it would help maintain the seal. Probably wouldn't take a whole lot of tension on that hose clamp, just to ensure solid mating all the way around. Probably more to keep rodents, insects, dust, water, other stuff out.
Yep.
Than really holding that mini flex cable secure in that location. Because there's likely not a lot of forces that are going to be pulling on that. Even, the temperature variation probably isn't going to amount to much in the way of travel. So it's just more about keeping the environment clean and
bug-free.
Bug-free. Yeah, that's important.
I mean, yeah. Ants, wasps, we all know that drill. Okay. So I want to go through a little bit about our a type of clip for when mounting, whether it's the microduct or the actual 3mm to the side of the substrate. And typically this is what we're used to, right? And this is designed for 3mm. where we have the captive screw in a U-shaped configuration. And from my experience, and I've seen this more often than I care to, where you take a hex driver, you put it over there, you got a nice straight line to begin with, and then when you bottom that screw out, and this happened a lot when you're dealing with like vinyl siding, because you got a polymer against a polymer. When you bottom that screw out, it tends to, unless you're holding that in place where it should be nice and perpendicular, if you're not holding that properly with like needle nose pliers or something like that, and that thing takes a twist, you're going to twist the cable.
Yeah, it's always going to rotate clockwise, right? Because that's the pressure of the driver, and when it bottoms out, that additional torque at the end is going to twist your clip. So that's pretty normal. Do you have the don't do's in here? Anything that involves a hammer?
No.
We should probably mention that. So don't use any clips that involve a hammer or a stapler. Those are bad.
Very bad. Do it. Just make no mistake that the underneath that jacket, that 3mm jacket, is glass. Glass will break. It will shatter.
I mean, because look, we've seen it for forever of a lot of legacy wire installations, whether it's Cat 3 or coaxial cable or Cat 5. There's a bunch of different ways of connecting that. And some of the old methods, again, I'll go back to the zip tie thing again, because it has to do with that tension of the zip tie. We've seen it in fiber splice trays, FOSCs, where your entry cables, when they exit the buffer tube, sometimes the technicians want to secure the buffer tube to the tray with the zip tie just to help hold that in place while they do their fiber routing and management inside the tray. And if you over tighten that zip tie, it'll actually compress either the buffer tube or the fiber and create a micro bend.
Okay.
Now, that's not inside of like this mini flex cable that has some rigidity on the exterior jacket to help support that and protect it. So I'm not suggesting that you could add fiber loss based on, zip tie impingement on this particular fiber, but it has happened in other applications where if you cinch that thing up too tight, it'll actually create a micro bend and cause some light loss.
Yeah, and I didn't like go through in the previous ones when you first saw the packet of zip ties. It is primarily for slack storage, like to make sure that once you coil up in the base plate of that NID, that you would use that for making sure you got a nice, for the upper part of the diameter, the lower part of the diameter, just making sure it's going to stay in place. But to your point about buffer tubing is far more resilient than the jacket of the 3mm mini flex. I don't think that you could physically choke down on it to create any type of impingement inside the 900 micron that's on the inside.
All right, so 5-minute warning. We got to start to land the plane. I think you have a video. So routing, just be careful when you're using clips, nothing that involves a hammer or a stapler, and be careful when you send those home that they don't rotate clockwise and bend your fiber.
Or you can use these clips that I think are unique to us. Shameless plug, but I really like these because you actually place the clips onto the substrate first, and then you simply, once you're done routing the clip, you snap the cable into the clip itself, whether it's 3mm or the microduct. There's no risk for the rotation, and the other part is like we're always dealing with slack, right? And so if we have to adjust our slack, we don't have to unscrew everything with the U-clips. We just snap it out and snap it back in, and once we get everything nice and tidy. Love these clips. Sorry.
Nice. You'll have to send me some.
Yeah. I can do that. So this is just a quick video of routing. No big deal. I'll skip through that given the 5-minute warning. I mean, I don't think you're at risk for like the microduct with the U-clips, but it's really more for like any of the drop cable going off to the side of the house.
Hey, I don't know who that actor was, but he looked a lot like you.
He's a little chubbier there. I don't know. Not as much
Is that
gray
your
on
stunt
the
double?
It is.
Oh wow.
What
Well,
do you think?
excellent. Yeah, excellent selection on the stunt double.
Thanks, Blake. So it's important to note, like with our cable, the 3 millimeter, it's what we would call a loose tube construction. And that makes it very nice for manipulation. Unlike the previous flat drop, whatever you want to call it, where you really had to be careful on how you manage your slack storage. This is very forgiving in that your fiber core, your 900, sits in a pocket within inside the 3 millimeter jacket, the copper tone wire, and then your aramid for strength. This all just floats inside there. And what makes it nice, so this is a little bit more of the construction of it. Tone wire, there's your jacket, tone wire, aramid for strength, and then your 900 micron fiber. All sits and floats inside the ID of this jacket.
Wow, and that's really, really small. So a lot of precision involved in getting all that stuff to properly float inside of that cable.
Yep. And so this would be like a standard reel that we would supply the 3 millimeter with. And so, you're always going to deal with, if I got 100-foot length and my next size up of reel length is 150, it means I have to deal with 50 feet of slack, right? And what's nice about this is that the cardboard that it comes with, once you're done and you've reached your endpoints, and you just simply, for your slack, you just rip apart the cardboard and you already got it all spooled up. So it's almost like a pre-slack scenario.
Nice.
Clean, 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 please clean. So this is just walking through the connection point to the NAP with the HFOC connector.
If we haven't mentioned, fiber cleanliness is important.
It is, highly.
All right,
Yes,
so that would
correct.
be in the NAP and the pedestal.
Yeah.
And there is a secure threaded body on that to help maintain the security and the moisture
Sealing.
prevention of the connector. Yeah.
And that gives you you have an arrow on the connector, you have an arrow on the port that you're going to make the alignment with. Make sure you pay attention to that. And I think we're at the end, Mike.
Easy peasy. So I think once or twice we've mentioned how important fiber end face inspection and cleanliness is. Did you have a demonstration you wanted to show us what a dirty or a clean fiber end face looks like?
Let's see.
Ooh, look at that.
Huh?
Yeah, look at that. That one's pretty. All the
right,
zones.
So I have, with courtesy of Viavi, I have my desktop micro scope checker, which again, it's digital, so I'm not peering in directly to any light source. And then I have just a very simple, small jumper with two ends on it. And so when we go ahead and we want to characterize what the end face of the connector is, you don't always want to go ahead and clean it immediately. I want to know if it's clean or dirty first. Because if I don't have to have that wiping action up against the end face, I don't want to do that. So my first objective is just to simply characterize, and I'll insert it into the end face of the microscope, and I'll go live. And that's what it looks like, okay? From my experience, this is a very clean, let me just zoom in a little bit.
And I'll run the test. There had been some stuff out in the outer zones, but it was far enough away from the actual core of the end face.
Right, and the beauty is once I hit the test button, it means I need better focus. Just get a little bit here. Bear with me.
Yeah, I thought about him in my eyes there for a moment. Ah, there it is.
So you can see on the lower over here, kind of once I'm in the green, then I go ahead and perform the test. And it's giving me a little blip out here, but it's nothing that's going to interfere with the actual light source, which is the core of the fiber itself.
Yeah.
Now let's say.
The question is, does Skip have cooties?
Let's say I have an itch on my nose and I'm working and I go, oh, that feels good. Let's see
Because
what.
that never happens.
No, no.
Oh my God.
There's the net result of my filthy face on the end face of a connector. Shall we test?
Skip, you are a walking biohazard.
I'm not the only one. I
No, you're
trust
not.
me.
Every human, I've done this 1,000 times, and I find it wildly entertaining every time. Call it the sophomoric humor that I still possess,
I
but
know.
it is hilarious. Your skin, even after you wash it, is going to pick up oils and dust and just microscopic stuff from the air, and you never notice it. But the
No.
reality is, if you touch a fiber end face to any part of your body, your choice, and then put it under a microscope, you might be dismayed at what stuff you're carrying around on your skin.
Yeah, it's look, I'm not proud of showing this image to the world, but it is what it is. I mean, so I did the test, and we have 4 zones, and I failed 3 of the 4. I'm not even sure which one I actually passed, probably the geometry test, but so this is a filthy end face, and I'm going to take this poor name.
One click. One click. Let's see what happens.
Let's do just that. So let's one click it, and we could be successful. I don't know. Let's see what we get. So we'll go live,
Oh,
and we
look at
still.
that.
It's not bad.
It's not bad. There's still a little bit of cooties. And I think I told you this before, but we used to have kids from like the local STEAM programs or STEM or science programs come into our Comcast facility in Pittsburgh, and we do demonstrations on fiber stuff. And I always use this test to conclusively prove that that girls have cooties, and so do boys.
It's true.
It is, yeah. Everybody's got cooties.
So let's test.
That's actually not terrible for one click, but to your point, one click might not be enough. And, it was a pretty blatant demonstration of, scratching your face with a connector. But the reality is incidental contact on your shirt can pick up lint or, debris, fuzz, microscopic stuff that you can't see until you look at it under a microscope. And if that thing lands on the core, man, the worst part is it may not actually show up in an optical power measurement. Because, specific to PON, there is this massive range of optical powers that are acceptable based on your fiber link budget and your total loss budget. You may have negative 20 dBm, or you may have negative 5 dBm, whatever. I know some of them will work up to nearly negative 30. So you may still have an acceptable margin of error on your optical power budget, but qualitatively, if that fiber end face is clean or has some debris on it, your signal quality might be impaired.
Yep.
And result in, packet loss, poor customer experience, all kinds of negative consequence for something as simple as failing to properly clean and scope your fibers.
Yep. Not to mention reflections.
Yeah. Do you want to try it one more time and see if 2 clicks is enough? And then maybe we can call it the 2-click cleaner.
Click until clean.
I mean, I think our audience really wants to know, does 2 clicks get rid of cooties? Or does it take more than that? And I think in this instance, there's still some funk on there, even though it does pass.
Yeah. But that's the other thing I really like about the digital. I got one little artifact over here or whatever it may be, but the fact that, this easily tests all 4 zones of what's important to making sure I have a good connection. It just automatically tells me if I'm good or bad.
So as we land this plane, Skip, I want to thank you because, I think we covered all aspects of the installation of a fiber optic network from the pedestal, the NAP, all the way through to the ONU, ONT, through the outside box, the NID, the duct mounting or fiber mounting. And a couple of things that really jump out about this is man, you really got to pay attention to your fiber end faces, the routing of your duct, and and then, the management of your storage. And you guys have some great products, whether it's the fiber, the connectors, or the fiber management box. So when all that stuff is done, everybody recognizes that there's some inherent reliabilities in fiber optic deployments. They're ingress resistant, they're passive, so the power consumption in the outside plant network. There's if provided that you get the installation right and take all of the necessary precautions from your duct routing to your fiber install, your connector installation, to your end face cleanliness, in the routing of your cables. This could be the difference between a really good, reliable customer experience, free of trouble calls and a lot of maintenance,
Repeats.
to repeat service calls, poor customer experience, unreliable service. So it's really not rocket science, but there is some craft sensitivities that have to be sort of cared for at the time of installation. Am I thinking about that right?
You are. I mean, if you do, it's there's craft sensitivities involved, and again, I can't put enough emphasis on making sure you have good straight lines when it comes to the fiber, and you're not creating macro bends with it. But again, nothing is more important. And from my perspective and my experience out in the field is making sure that those end faces are clean and you're doing all the other things correctly.
Yeah.
But it winds up being a much more robust architecture compared to coax, quite frankly, because you're not dealing with ingress egress with it.
Yeah, now there are some differences though, right? We have, especially when you get into the routing around the house, we've had direct bury coaxial cables that, just sit in the ground exposed to that moisture and, the tension of the ground. And then inside the home, all of that stuff's exposed because we typically don't run coax through duct. So that's where, the clips, the staples, the bends, the abrasion, like all of that stuff can impact the structural and electrical properties of the coax. Whereas fiber, it seems like is a little more protected structurally and in the routing. But so not to say that coax is bad and fiber is good, because I'm a huge fan of coaxial cable, love it. There are systems that are running multi-gig symmetrical over a coax now in DOCSIS 4. So speed isn't really the issue. There's low latency in both architectures, but the craft sensitivities are different. And I really appreciate you walking us through, the craft sensitivities and the care and feeding of the drop system in a fiber network for the best possible outcomes. So our technicians will thank you, our customers will thank you, and us at the Penn Ohio chapter, of course, thank you, Skip, for being such a great partner and spending your time and expertise with us through these last couple of sessions. So thank you, and PPC Belden, for your continued partnership and subject matter expertise, my friend.
Thank you for inviting me in and allow us to share. Appreciate it.
All right. So Penn Ohio family, there you have it. Fiber drop maintenance or care and feeding 201. Don't forget to like and subscribe. If you appreciate our content, hit that notification bell and you'll get notified when we drop new content Monday, Wednesdays, and Fridays. And as always, until next time we talk, stay safe out there on purpose.
Take care.